Let's see, does it work now? Okay, so I'm turning on the audio. So, okay, so first of all, let me see if I'm actually out there. Um, Wait, is this September 2nd? Yeah. So apparently that's us. Okay. Do I have audio? Oh, yeah, I got it. Okay, so with all this in mind, let's just, I guess, this. Okay, push all the buttons until something happens. Every button, push it harder, push it again, maybe push that button. This button, it varies from day to day. So the problem is you don't have a code, you got your code, it got canceled. You go back to the bookstore and they'll refund your money and you turn around and rebuy the same thing. So they'll fix it. Then when you get the thing, it goes to this, and then there you click on the top right of the little information for each course. And that, okay, is that all right. So you know what? I'll use this same picture in my other course. So maybe by later today, I'll write all this in a text and send it back out to you guys. So, but most of it, so like you said, you already know how to do it. So let me just do one seemingly simple thing and just, so what I'm going to do is take a vector. Here, let me make sure that sometimes it's hard to, the camera, the display part of the camera doesn't work anymore. So, okay, it looks like it goes from about right here this time. I don't know. Let's say you just had a vector A that was set out here, and here's your X, and here's your Y coordinate, and obviously you can break it into components. Your components, you could break it into a cosine of theta. Well, here, let me write it right here. A cosine theta on the I, and a sine of theta on the J. Now, if you think about it, maybe I should I'll draw a box around these to get your attention to these things. These remain fixed. Nobody I've ever talked to has ever changed the direction nor the magnitude of the I or the J. However, here, let me do this. However, if you get in polar coordinates, things look a little weird. And the reason they look weird is they want the base vectors to kind of be that, where this UR points directly up in the direction of A and is unit length. This is unit length and that's unit length. So they're base vectors. So now, in a polar, okay, so polar coordinates, stare at this and you think to yourself, this is really weird. How do I write this in polar coordinates? Well, what you do, you write the length of it. Let's just make this up as being 10. And you do like that. Now, if you stare at it for like, I don't know, maybe 10 minutes or so, or 5 minutes or 1 minute, let me go back and renege what I just said, and let's say I'm going to keep it back like a variable length. So this is the A here that I'm writing is equal to the magnitude of A. So actually, maybe I should write that. So if you look at this part, and then you look at that part, and you say to yourself, hey, wait a minute. If I set this A, here, I'll do it like this. I mean, I could say, how should I say it? Set equal to. How about that? Set equal to. And then what I would get, so I'm rewriting it, but equals to A and you stare at it a minute, and of course now I'm going to erase this and say I've set this one equal to that one. And now what I'm going to do, I'm going to delete that with the sound effects, and then I'm going to delete that. And suddenly you got a relationship between that base vector right there and these that don't change. So again, here, I've already written that up there, so these remain fixed. So throughout time, this vector changes in its direction. If that remains fixed and that remains fixed, then here, let me move my equal over. Or let me, maybe I'll move this back a little bit. Or I'll basically say this. I'll just write it in words. Actually, theta is a function of time. So UR is as well. So in other words, if this little vector is spinning around or something, say it's on a flywheel, we'll just say that for the moment. It doesn't have to be. So you painted a spot on a wheel, and you painted that spot, and it just goes round and around and around. Well, then over at this time, this is UR. Over at this time, this is UR. So it just changes throughout time. That leaves us with this U theta. And if you stare at it for a minute, rewrite this, not rewrite, but redraw it. Here, I'll redraw it again. This time, I won't put on the X and I won't put this here. I'm going to take this vector and move it down to here. There's my UR. There's my U theta. Of course, my I goes out here, and my J goes out here, and that's theta, and that's theta. Now, what I can do is do this, and what you find out is this is just, I know, I'll move this one to that one. So this length right here is 1 cosine theta times I. And the reason it's 1 is because this vector length is 1. So in other words, UR, the length is equal to u theta length is equal to the length of I, which is length of j, which is just 1. So in fact, that's cosine theta, this length, and that's sine of theta. If you stare at it a minute, you realize that value, that's the direction. This value is that distance here, and that's the direction there. This you are from this, or you could have redrawn it and got it from this. So now, I have that sit here and stare at the u theta. I'm trying to take a little extra time, trying not to be rushed today. So this is 1, of course, and it's actually sine of theta, but it's going backwards. And this distance is cosine of theta. So if you stare at that u theta, you'll see this. I got to be careful about this. Sorry. Oh, gosh. Okay, so you stare at this for just a minute. That's all you're wanting to do. Stare at it and say, okay, I'm just looking for this vector. It's going backwards along the x, and its value is sine. It's going up, cosine. This distance is the same here, and j. So both UR and U theta will change throughout time. So what do I do with it now? Let me stop and get a drink here. What I do with it is kind of interesting, and that is let's assume now, I mean, it could be position or whatever, but let's assume that A is actually a velocity. Could have been position, but let's just assume that A is equal to velocity. So now I want to write the velocity vector. It's equal to, I'm going to write it in polar, some value, say, I'm just going to make this up, 10 times UR. I could have just as easily did that as a position, but I just thought, I don't know. So what do I do if I'm in polar? Maybe let's just make it a position here. The position vector, R, of a particle. So there's a particle here, and we're going to track it. So now I'm going to find the velocity. So if I want to find the velocity, I take a derivative with respect to time of the R. If I'd have left it as V, I would have been finding the acceleration, but it's more traditional to do this with R. Well, the 10 might not change, but let's make it so that it could. So let's just say I'm going to have a position vector, which actually maybe, okay, I got red, so let's say maybe this is the particle. Maybe it's doing like that. So it could change its distance to it. You draw a vector, you change its distance. So the distance from here to here is different than the distance from here to here, all along that path. So it can change. So now I would basically do this. Now, if I have to be careful here. Let me write it in its complete sense. And draw your attention to this term. Now, if I had done this in a Cartesian system, I'm going to erase this in a second, and I'll say x, I plus yj, and I had those as a function of time, the i's and j's don't change. So you would never have this derivative here, or the derivative would just be 0. So in fact, this is an oddball thing in that the base vector changes with respect to time. So now I could focus here, I could focus here, or here, but I'm going to focus my attention here because I'm looking at, once I have this value, I could insert it here. So let's just focus all of our attention here. And when we finish focusing our attention, we'll leave. And we'll come back to this. So we know this thing is a function of time. And we know this is not a function of time, but this is. And so if I just want to come in here and say this, then I'm just taking a derivative. Well, let me scoot this over and be very specific about this. I'm going to scoot this over. I'm going to say cosine of theta, which is a function of time. And I'm going to scoot this one over. And I'm going to say sine theta, which is a function of time. Nothing fancy, it's just that. Well, I think I can take the derivative of the cosine. I think that's a minus the sine, I think. And the I just gets copied down because it remains fixed. If I take the derivative of the I get nothing. And so then take the derivative of the sine, I get a cosine. Okay, so then if you look at this from a relationship viewpoint, stare at it really close for a minute, and you'll see it appears somewhere else. And so it's kind of weird. The rate of change of this vector is that one. And the rate of change of this one is actually not this one, it's the minus of that one. And so we can show that too. Now, we don't see a reason for taking a derivative here yet, but we will later. But let's just fill it in and fill in the gaps. And then before we take off and do anything, I'm going to let that kind of settle in. So let's just say I know somewhere down the line I'm going to have to do this. So if I take the derivative of the sine, that minus sign stays there. I get that. Derivative of cosine is minus the sine. Now if you stare at that for just a few seconds, you realize this equals 2 minus UR. And this derivative, is equal to that. Now what he does in the book is he shows these little graphical things, vectors here and there, and he just says, oh, this is that. And that's all he really says. But in this instance, you know, to me, it seems kind of asinine in a way to be forced to take trig and calculus and then to not necessarily use it when it's of great value. So to me, you can show a couple of vectors and you can just wave your hands and say things, but why not just spend, you know, this could have been done on, I mean, that's not that much right there. That's like one little column here. And I guess I could have done this somewhere, and then maybe this could have, these two could be together. So you could easily put that all together and then some words around it and made the same argument that mathematically, what you're trying to get, your final thing, you box it and you make it in color and you put asterisks around it and you draw arrows to it. And this is your point. This is what you're actually wanting to say But the math, actually, I didn't have to draw some vectors and convince you. Someone else told you how to take derivative of cosine and a sine, and that was either last semester or the semester before, or maybe you had it in high school, I don't know. Or I don't know where you had it. I don't know when I had it. So to me, I can write this down. I can extract it this way by comparing, or I can take that vector, move it to the axis, break it in its components, and write both this vector and that vector. And then I can take the derivative of this vector, and I can take the derivative of that vector. But the reason I'm doing that is because it shows up in here. There is times when, and you don't see the derivative of a theta yet, but you will, and I don't want to distract the point yet by saying this is when you see this, because the main point here is that and that, and that the change in this vector, this little UR, with respect to time, is that one. And the change of this vector with respect to time is a vector pointing one this way. That's it. That's all you want to get out of this right now. Once we have those two things, we'll use those. And I'm kind of hesitant to even go there yet. I mean, we'll do that. Today's Friday, isn't it? So we'll do that next time. Now, so you had an initial point or question, and like, was there supposed to be a test today? Well, today's the 1st. No, I'm sorry, 2nd. I'm sorry. Okay, so I think I have the homework. Okay, I have the homework set to be due on the 11th, and I'm gonna try to make all those Sunday night at midnight. How about just say midnight? Midnight. It sets it up so it's midnight minus a minute. They don't like to put. I think. Maybe it confused people when you put 12, because sometimes, so it sets it up so the 11th at 11:59. And my goal is I'm going to look at that assignment, target, okay, so that's Sunday, okay, Monday, Tuesday, Wednesday, Thursday, Friday, it'll be 12, 13, 14, 15, 16. So the test, the quiz, will open that morning. I can't remember if it was midnight, and it'll be remaining open till that day at midnight. So I think it's 48 hours. And so during that time, you could pick up the test anytime you want, or you can come here and take it if you want. It's up to you. Generally, it's 1, 2, or 3 little problems that most of the time will be extracted from this. So I don't know if in yours it specifically says there are hints, but there are times when you can, on mine it'll say, like problem 212 with hints and something else. Hints and examples, or hints and something. And then it'll have it right under there. It'll say the same number with no hints. And so what I'll do is probably put some hints, pick those with hints, and then pick the one without hints here. So if you do the assignment, there's a good chance you will have already seen 1 or 2 of those things, maybe even all 3. And that's the other thing too. I've got to go back. To me, I got confused. There are 3 dates. To me, I thought there was 2 dates. It makes sense to me that there are 2 dates. There's a date. Okay, so for example, every assignment has this date. Actually, there are 4 dates. And then there's a visibility date. I don't even know. Visible, V-I-S. That's not spelled, but anyway. And so I was having trouble with that, and so I put all these assignments out there, but you can't see them yet. So now I've got to sit over the weekend and go back to each of those assignments and move a visibility date back so you can see them, because you can already start going through the homework. Now, the visibility and execution date on the homework is anytime. So you can start doing the homework 2 or 3 weeks ahead, but the execution date, I made these that the minute they're visible, you can start doing them. These are not, you can see them, you can click them, and I don't know what it tells you. It may say you can't take this yet, but these you can start taking. So the way I'm going to plan this is every Sunday, midnight, the homework. And then every Friday, or actually I could say Thursday morning, or say Friday, every minute of all day Friday, and then all day Saturday, you've got that you can take that. When that window closes, it closes. And then I kind of thought I wanted to do that because then the next week, Sunday, you're going to be looking at next assignment. So I don't want to get things, I want you to do this one early and then focus your time on Friday, Saturday. If you need to relax on Sunday, that's fine. I get it. But these, you know, that's the other thing. These are pop and go. These are one time and you're out, you know. So that's the way I kind of view a test, you know. So this is to help you learn. There'll be things in here sometimes that'll be, what are they called? Coaching activities. And I was like, what is that? So I clicked on it, went down through it, and I was like, well, that's okay. It's kind of a part of the book with some videos and then like a little questionnaire at the bottom of it. And I thought, that's okay for a homework. You know, you just complete it and then you answer the question, you go on. The homework, I mean, so don't get like stressed out if you get like 8 out of 10 there, you know, or something like that. Or this one is the one that's going to be, the number is actually the number. To me, there'll be a lot of flexibility and actual curving on that, but I want you to be able to use this to learn it. You got 5 attempts and 6 shots, I guess it's called shots, within each of those. And I think the way it works, and you could tell me probably more than I think, from me reading it, it won't let me take the whole thing, so I can't figure out. I wish I could log in as a student and come in and see what you see. It's kind of weird. My impression is, you say you have 5 problems. You're looking at the second one, say, and you don't get it. Instead of having to do the first one and the second one again, you could just do it over and over, I think 6 times inside that attempt, which kind of means you probably wouldn't even need 5 attempts. You probably just need 1 and 6 shots within for each problem inside each one. Does that make sense? If that's not the case, let me know, and I'll see what I can do on my end. It's a good system, don't get me wrong, but it has a set of things, and it classifies homework, quizzes, and tests. And each one of them has different options, which I can go in and change, but they have defaults. And so I need to know if I need to make a change to that for the defaults. So,
are we taking our final on this as well?
I'm hoping so. I think I can arrange it.